Dear friends, welcome to VK Lectures. We are going to study today mathematical physics. In the last class, we have seen the analytical function, how to check analytical functions. Now, another condition also required to check the analytical function we are going to introduce today. That is, for a function f of z to be analytic, its real part and imaginary part should satisfy Laplace equation. Laplace equation means del square u is equal to 0 and del square v is equal to 0. And we can also say if f of z is analytic, u of xy and v of xy are harmonic. Harmonic conjugate which satisfy Laplace equation. And a very useful thing from here is if u of xy is given, we can find v of xy, and if v of xy is given, we can find u of xy. Next, if f of z is analytic, then closed integral of f of z into dz is equal to 0, which means integral c f of z dz is independent of path followed. For example, this is the graph. This is an initial point. This is final point. This is f of z. So here this is independent of the path followed. We can integrate with the initial and final point. We need not consider the whole path. In this example, we only need to find the integral of c f of z dz. initial and final point is only considering. Because, why we are doing like this? Because f of z is analytic. Therefore, we need to find closed integral f of z dz from initial to final. Now we are going to discuss the applications of this. First, if real part is given, we can find imaginary part, and if imaginary part is given, we can find real part. And second application, if u of xy is given, we can find v of xy. How we are going to do this is, we know using CR equation, dou u by dou x, we will get an answer. Similarly, dou u by dou y, we will get an answer. And dou v by dou y is equal to, we need to find from here. We need to find from here, and this also minus dou v by dou x we can find this from here. Okay, which means dou v by dou y is equal to integral of dou v dou v. So v is equal to integration answer. After integration, we will get answer. And similarly, minus dou v by dou x is equal to integration we are doing with respect to x. Then we are getting, let this first we obtain, take it as 1, and second we, after integration, after integration, take it as 2. Then final answer is addition of 1 plus 2. Integration of 1 and integration of 2. Add both v but not add repeated terms in both. One point we need to remember is final answer addition of answer v. The we should obtain is addition of the integration of both the v's, but in that addition, if the repeated terms is there, avoid that. That means add both v but not add repeated terms in both. This after solving one problem, you will get the idea. For example, q of xy is given as x square minus y square, and find v of xy is the question. Then dou u by dou x is equal to 2x, and dou u by dou y is equal to minus 2y, and therefore we can say, since dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus of dou v by dou x, so we can write dou v by dou x is equal to 2x, or dou v is equal to integral of 2x dou y, which is equal to v is equal to 2xy. This is the first integration answer. Then similarly, minus dou v by dou x is equal to minus 2y. So that is dou v is equal to integral of 2y dou x, which is equal to v is equal to 2xy. This is the second integration. But since both the answer is same, we only need to take v as answer. V of xy is equal to 2xy. We don't need to add the repeated terms. We need not take to add. Okay. So this is the procedure to find v of xy. Now we are going to study a CSIR question. Which has asked in the CSIR paper. Which I am mentioning as CSIR questions. This means that these problems has been asked in CSIR paper. So u of xy is equal to x plus half x square minus y square. So dou u by dou x is equal to 1 plus x, and dou u by dou y is equal to minus y. So from here we can write, since dou u by dou x is equal to dou v by dou y, it is equal to 1 plus x, and dou u by dou y is equal to minus dou v by dou x is equal to minus y. So here v is equal to integral of 1 plus x dou v is equal to integral of 1 plus x dou y. It is equal to y plus xy. This is integration 1, and here dou v is equal to integral of minus y dou x, which is equal to minus of minus plus, so that is equal to xy. This is the integration 2. This we got entire different answers, so we need to add up the function, add up the both integration part to get v of xy. So answer, therefore v of xy is equal to y plus xy, y plus xy, and xy is repeated, so we only need to take y plus xy. So this is the answer. This has asked in the CSIR question paper. Alpha is equal to 1, beta is equal to 2, and gamma is equal to minus 1. And next is the question asked in JEST. If f of xy is equal to phi of xy plus I psi of xy, if phi of xy is equal to x square plus 4x minus y square plus 2xy, find psi of xy. Solution: dou phi by dou x is equal to 2x plus 4 plus 2y. Therefore, psi is equal to 2xy plus 4y plus y square, and dou phi by dou y is equal to minus 2y plus 2x, which is equal to minus dou psi by dou x, so which is equal to psi, answer 2xy minus x square. Therefore, we got psi of xy is equal to minus x square plus y square plus 4y plus 2xy. Now, u of xy is equal to e raised to now we are going to study about the third application, that is real part is given. We need to find f of z. using Milne-Thompson method. We are going to study this or solve this. So, u of xy is given. Then we need to find f of z. So, dou u by dou x is equal to f1. Put x is equal to z and y is equal to 0. Then f1 of z0 we are going to get. And dou u by dou y, we are getting some answer, right? f2. Put x is equal to z and y is equal to 0 here. Then f2 of z0, we are going to get some answer. Then f of z is equal to integral of f1 of z0 dz minus I of integral f2 of z0 dz. This is the format. This is how we are going to find the f of z. So problem based on that. Example 1. U of xy is equal to e raised to minus 2xy sine of x square minus y square. So dou u by dou x at x is equal to z, y is equal to 0 is equal to e raised to minus 2xy into minus 2y sine of x square minus y square plus e raised to minus 2xy cos of x square minus y square 2x. So f1 of z0 is equal to 2z cos z square. Similarly, dou u by dou y at is x is equal to z and y is equal to 0 is equal to e raised to minus 2xy minus 2x sine x square minus y square plus e raised to minus 2xy cos x square minus y square minus 2y. So f2 of z0 is equal to minus 2z sine z square. So we got f of z as integral of f1 minus I f of z f1 minus I f2 into dz. That means integral of 2z cos z square dz minus I integral of minus of 2z sine z square dz. That is equal to integral 2z cos z square dz plus I integral of 2z sine z square dz. That is equal to integral 2z cos t dt by dz dt by 2z plus I integral 2z sin t dt by 2z. I hope you know everyone to substitute. Put z square is equal to t, 2z, dz is equal to dt. So dz is equal to dt by 2z. Then we got sin t minus I cos t, f of z, or f of z is equal to sin, this is not f, this is f of t, this is f of t, then f of z is equal to sin z square minus I cos z square. Or in other words, we can write this is minus I e raised to I z square. In terms of e raised to I, we can write. So this is the answer. These are the applications of analytical functions. So now in this next video, we are going to study about singularities. Thank you.